recording. Okay, now we're recording. So power for a circuit is going to be IV. So power is equal to current times voltage. And you still use watts. We're still going to wind up using watts here. Other equations that can work for electrical power are down below. So remember, V equals IR. So P equals IV. Guess what? You can replace V with IR. You get that. Or, remember, I equals V over R. So P equals IV. V over R times V is V squared over R. So there are three varieties for power. That's one, that's another. Doesn't matter which one you use, but kind of just depends on what you're given. Like if you're given current and voltage, use P equals IV. If you're given current and resistance, use I squared R. If you're given voltage and resistance, use V squared over R. So right, but as long as you have V equals IR, P equals IV is fine. You just might have to use an extra equation. V equals IR, Ohm's law. So that's what's happening there. So let's look at a home appliance problem. You have an electric heater. The resistance of electric heater is 1430 ohms. Operates at that voltage. You want the power rating of that heater. And how much electrical energy does it use in 24 hours? Okay, I think that's kind of a good problem. And that's kind of good to know because, yeah, what if you're like heating your spa forever? Or just you're running, you're taking running hot water for, I don't know why you would run hot water for an hour, but yeah, electric heater. Or it could be running the heater in your house. Sometimes some people use gas mainly for gas furnaces, but what if you have an electric furnace? You know, I don't know. So anyway, we'll use the V squared over R, because remember that's R, that's V. So 120 squared over 1430. And you can use a calculator to work that out. You get 10.1 watts. That's a real easy calculation, super easy. Then, what is a watt? Does anyone remember what a watt is in terms of joules and seconds? In case you forget, you go to your notes.
Is it joules over seconds?
Yep. And if you look at, thank you for whoever chimed in there. Yeah, if you go to chapter 3, excuse me, on power, it was 3.4. It's right there. It was, well, I put it somewhere in the notes. Yeah, there we go, joules per second. Yep. So 1 watt is 1 joule per second. You're trying to get energy. Energy is in joules. So all you have to do, let me clear some of this other stuff because we don't need it anymore. Okay. All right. Come on, my mouse is acting up here. Okay. So yeah, so 10.1 joules per second, and 24 hours. Remember, 1 hour is 3,600 seconds. Use a calculator. 3600 times 24. Those cancel. So you have this. So it's a lot of joules you're using. So anyway, that's that one. Let's look at kilowatt hours. This is kind of a good one because this is more relevant to like what we tend to see with like your energy bill. So electric companies charge you for the amount of electrical energy you use. Duh, obviously. It's measured in kilowatt hours, or kWh for short. So if that's actually energy, so it's using power times time. So kilowatt hour is the amount of energy used in 1 hour. So say it costs you 15 cents per kilowatt hour, your electricity bill, we'll just say that. That's what they charge you. Then how much does it cost to operate the previous heater? Which only, so 10.1 watts. And we're doing this for 1 month, okay? So let's think about this here. Okay, we're doing this for 1 month, got it. So let's assume 1 month equals 30 days. So let's say the month of June, which just passed. Also, 1 day equals 24 hours. We know this. So 1 month equals 720 hours. So 1 month equals 720 hours. Now again, you're charged 15 cents per kilowatt hour. So all you have to do is just realize, okay, how much energy I'm using here. So we know that the power here, the heater's power rating is 10.1 watts from the previous problem, or 0.0101 watts. So 0.0101 watts. Sorry, kilowatts, yikes. So all you need to do, let me erase this stuff here. So the energy we use is going to be my kilowatts times 720 hours. So that's 7.272 kilowatt hours. And it's costing 15 cents. per kilowatt hour. So you work that out, it's only $1.09, which I kind of don't believe, because I know heater costs a lot more than that, but for the sake of this problem, that's what it'll cost you, $1.09. So what you have to do is you have to calculate the power, which we did in the previous problem, figure out how long you're running it. So the kilowatts times hours gets you the energy unit you want, which is kilowatt hours. And of course, you're given the price per kilowatt hour, and you just multiply them together. So that's what we see there. So let's do some practice problems in breakout rooms. So just so you guys get a little practice of this. Excuse me. So let's do, excuse me here, maybe 5 through 10. Let's go and check here. Yeah, we'll do 5 to 10. And then we'll come back. So we'll do this for about 10 minutes. We'll talk about it, and then we'll break for lunch. And then when we come back from lunch, I think we'll do some stuff on, we'll kind of come back to waves again. Actually more like sound. There's a really good problem I want to talk about, sound, like good concept. And then maybe close in a class, we could just kind of look at some of the review problems from this, even though we're not doing a test today. So yeah, let me clear this right now. I could probably stop the recording.